Welcome to our video on gas sensor, fundamental devices in numerous safety and environmental monitoring applications. Today, we will explore what a gas sensor measures, its story, how they work, and the real-world applications. What does a gas sensor measure? Let's start with the basics. A gas sensor is a device designed to detect the presence of concentration of gases in the environment. They can measure various types of gases, from flammable and toxic gases to natural gases present in the atmosphere. The history of gas sensor dates to the 19th century. In 1830, the German chemist Emil Michelich created the first gas sensor, a glass tube filled with platinum, which changed its electrical resistance in the presence of specific gases. This invention laid the foundation for the future developments. Now let's talk about the classification of gas sensor and the physical principle behind them. This sensor uses chemical reaction at electrodes to detect gases. In electrochemical sensor, an electrolyte solution is in contact with three electrodes: a working electrode, a reference electrode, and a counter electrode. When a specific gas comes in contact with the working electrode, an electrochemical reaction takes place that generates an electric current. The intensity of the current is directly related to the concentration of the gas in the environment. For example, carbon monoxide CO sensor is household CO detector operate on his principle. When CO is detected, the electrochemical reaction generates a signal that triggers a CO alarm. One of the most common electrochemical sensors are oxygen sensors such as the Me2O2, whose price range between 100,000 and 200,000 Colombian pesos, or between $20 and $45. Another common one is the three electrode exhaust gas sensor COSO2NOx, such as the AV526W0A, which can cost more than 1 million Colombian pesos or more than $230. These sensors are based on changes in the electrical conductivity of a semiconductor material when gases come in contact with it. The semiconductor material is sandwiched between two electrodes and acts as a resistor. When the gas interacts with the semiconductor material, it changes its conductivity, resulting in a measurable change in electrical resistance. As an example, metal oxide gas sensors, such as those used in industrial gas detector, work on this principle. When a flammable gas comes into contact with the metal oxide, a change in conductivity occurs, which is used to detect the presence of the gas. The semiconductor-based sensors are the most common and have an infinite number of references, with prices ranging from $2 to $40, or between 8,000 and 170,000 Colombian pesos. They exist for many gases. Some reference can be the MQ8 for hydrogen or the MQ6 for propane. Catalytic sensors detect flammable gases by measuring change in the rate of catalytic reaction in the presence of the gas. This sensor uses a catalytic material, usually platinum, which accelerates the oxidation reaction of the flammable gas in the presence of oxygen. The amount of heat released or consumed during this reaction correlates with the concentration of the flammable gas. An example application will be gas leak detectors in industrial environment and home security system that use catalytic sensors to detect the presence of combustible gas. When the gas concentration reaches a dangerous level, a catalytic reaction occurs and an alarm is triggered. These sensors are quite reliable due to their sensitivity and longevity. Some of the best known references can be the P0420 for oxygen, which value of around $4 or 14,000 Colombian pesos. On the other hand, you can find references such as combustion gas detector as the MC series, which has price of around $2 or 8,000 Colombian pesos. Gas sensors have a wide range of real-world applications. Let's look at some of the most common ones. At home, carbon monoxide and natural gas detectors are crucial to prevent poisoning and explosions. In industrial environments, they are used to monitor the presence of toxic and combustible gases in chemical plants and refineries. Gas sensors are used in air quality control systems in buildings and offices to ensure a healthy environment. In the utility industry and in the home, these sensors detect gas leaks and help prevent accidents. Gas sensors are also used in space missions to monitoring and analyze the atmospheric composition of other planets, or by monitoring the air condition inside the vessels or stations. In summary, gas sensors are essential devices that measure the concentration of gases in the environment, and their history, classification, and application are wide and varied. From home security to space exploration, these devices play a vital role in everyday life and scientific research. We hope this video has provided you with a deeper understanding of gas sensors and their importance in the modern world.